Okay, this is Professor Hildebrandt here. And so for chapter 5, I've actually decided I'm going to break this chapter down into some smaller pieces. And so you guys can hopefully just come and listen to the recordings for the sections of this chapter on probability that you need the most help with. So in this first part of chapter 5, I'm going to go over some basic terms and introduction, and then look at the classical and empirical approaches to probability. So in Unit 1, we were looking at descriptive statistics, things that basically summarize data that's been previously collected from past events. And so now in this second unit on probability, we're going to focus on computing the chance that something will occur in the future. And so our basic definition of probability, it's going to be a value between 0 and 1, and it's going to tell us the likelihood that something is going to happen. We say that, the closer it is to 0, then it's highly unlikely. And so you can see on this chart here, the probability that our sun will disappear this year, well, that's a 0. Good news, huh? But then if we look as the values get closer to 1, then the more and more likely that that event will occur this year. And so we see the chance that Florida will get rain, at least some rain this year. Well, that's a 1 because it's a sure thing. Florida will at least have one day this year where they have rain. Then we have just some definitions. So an experiment, an outcome, which is the result of the experiment, and then an event is a collection of outcomes from an experiment. And we have two examples here. So our experiment could be the roll of a die. And all the possible outcomes, well, we could observe any number from 1 to 6. Some possible events would be things like observing an even number, observing a number greater than 4, a less than 3, so on and so forth. The second example here is looking at the number of, or looking at the members of a board of directors and looking at their ages, okay? And you can see then there's several different ways. No one's over 60, one is over 62 or over 60, right? There's a lot of different possible outcomes from an experiment such as that. All right, so let's get on then to some of the actual calculations of probability. So figuring out the likelihood that something's going to happen. So this first one that I'm going to go through is called classical probability. And this definition applies when our outcomes are equally likely. Okay, I see my screen's messed up a little bit, but hopefully you can see the PowerPoint slides in Course 10 as well. So again, classical approach is used when our outcomes are equally likely to happen. So again, let's go back to the rolling of a die. Maybe our question could be, what is the probability of rolling an even number? Well, how many of the options? There's 6 total, right? 1, 2, 3, 4, 5, 6. So there's 6 possible or equally likely outcomes. How many of those are what we call favorable? For this question, favorable being an even number. Well, the answer's there, 2, 4, and 6, or 3. So you can see your equation here for a classical probability would take the number of favorable outcomes, 3, we would divide that by those 6 equally likely outcomes, and so our answer here is 0.5. And notice here we are bringing back some of the characteristics that were introduced in an earlier chapter. So our outcomes are going to be mutually exclusive. And again, this means that the event occurring means that none of the other events can occur at the same time. So if I just roll the die one time and I get a 2, I can't get any other answer on that first roll. I can only have a 2, okay? And then the second characteristic is that our outcomes are also collectively exhaustive. So one of the events must occur every time the experiment is conducted. So every time I roll the die, I record a new number as my outcome. And this classical approach is used a lot in games of chance, like rolling of dice or playing cards. It can also be used in settings such as lotteries, because the total number of outcomes is known before the experiment in that case as well. Okay, so our second approach is called empirical probability, or it's also known as relative frequency. And this is when the number of times an event happens is going to be divided by the number of total outcomes that were possible. This idea of law of large numbers basically says if we keep doing our experiments over and over and over, eventually we're going to get to what's called a true probability. So let's think about a quarter. I throw the quarter up, it'll land either on heads or tails. Now, you would think, well, it's a 50-50 shot. It'll either be one or the other, 50 chance either way. And if you start flipping that quarter, maybe you've done it 10 times and only 3 times have you gotten tails. And you start to think, okay, maybe I'm wrong. Maybe the probability isn't 50-50. But you just have to keep going. The more experiments you do, you would see that you'll get closer and closer to that true probability of a 0.5 chance of heads or a 0.5 chance of tails for that quarter. And so here's the equation that we would use. This example was NASA looking at the probability of a successful flight. And so they calculated out to see that their probability is very high. It's almost 1, right? 0.98. Well, how did they get that? Well, so far, they've had 121 successful flights out of a total number of flights of 123. And so you can see, again, the likelihood that their next flight would be successful is very high. So for the third approach here to probability, it's basically used when there's little or perhaps even no data available. In these cases, probability can be estimated subjectively. And so an individual would base this subjective probability on whatever information they do have available. So perhaps someone tries to estimate, the likelihood that the New England Patriots will be in the Super Bowl next year. Obviously, they'll look at things like the number of times they've been in the Super Bowl in the past. They'll probably look at things, what's their roster going to be, come fall 2020? Are they gaining new players? Are they losing big players, right? What's their competition like? There's a lot of different factors that could go into determining that type of subjective probability. And so finally here, just kind of summarizing, we can either have little to no information, in which case we use the subjective probability based on what information we do have, or when it is objective, we'll use the classical approach when there's an equally likely outcomes, or we'll use the empirical approach and base it on relative frequencies, the odds of something happening. I will work out a couple of examples and post those as well using both the classical and empirical approaches, but hopefully this helps some.